Welcome, my fellow assassins, to the Dark Assassins podcast, the show that dives deep into not just technology, but the concepts, software, and procedures behind it all, and explains it so simply that even your grandma can understand it. I'm your host, the Dark Assassin. So, in today's episode, we're talking about software development, specifically why people think that software development is kind of this magic or dark magic, witchcraft, sorcery, when in reality it's not, and it's actually quite simple. Obviously, the fact that I'm saying it's quite simple coming from a software developer, I understand why you might be laughing at that, because it is kind of funny. Of course, I would say something like that. But the point of this episode is just to kind of dive deep into the minds of a software developer and kind of pull back the curtain on software development, if you will, and kind of show you what goes on behind the scenes and show you that we're not, black magic, witches and warlocks, for example. So why do people kind of have this understanding that software development is kind of seen as black magic? Well, I think a lot of that goes to the fact that there's kind of a lack of understanding of what really goes into software development, what comprises software development, kind of the culture around software development. And I think a good parallel that you can, tie this to is back in the early 1900s when electricity and light bulbs were first coming onto the scene. I mean, everyone thought those were like some crazy witchcraft magic technology, mainly because, they didn't understand it. I mean, today a lot of people still, don't really understand it. They think it's, crazy cool that I turn this switch on and ooh, there's light. Just like, with software, it's like, ooh, I press this button and my screen changes colors or, whatever the case may be. So the reason why I kind of got this idea that, the average person, I guess you could say, doesn't really have a strong foundation or understanding of software development is a few years ago, I was working on this email application that was kind of like a dumbed down version of AOL Desktop, for those of you who are old enough to remember those days. But when I say it was an email application, I want to preface by saying it didn't actually send emails. So I couldn't, use this system and send something to my personal email or send something to my work email or send something to my friend's email. It didn't do any of that. It just simulated it. And by that, I mean, on this specific application, you could send an email and someone else with an account on the same specific application could read the email. So it wasn't going outside of the application at all. But I didn't think it was that hard. In hindsight, I didn't think it was that hard. Of course, again, of course I would say that I'm a software developer, blah, blah, blah. But initially, I did kind of think it was going to be a challenge because, you think about email and, there's a lot of stuff that goes into email, which is really the key to all of it, actually. Because there's so much that goes into it, you can break it down into these really small pieces. And once you break it down into these small pieces, it basically becomes trivial, which we're going to get into, breaking down these small pieces. But I mean, you think about it, you take this massive application and then you break it down into essentially, I'm just dealing with a string of text here. And that's essentially what it can eventually boil down to. And you can see that with any type of software development, from these large websites like, Facebook, Instagram, Snapchat, all these big companies, iOS, for example, Windows, Linux, any kind of software, you can break down these large pieces of software down into really, really small pieces that become really manageable and really trivial to implement. And that's what we're going to get into today. So, the core of software development is understanding data types. And basically, everything in software development can be broken down into these data types. And if you can't break it down into a data type, well, you can make an object for it. What is an object? We're going to get into that. So, the main types of data types you have are integers, which are just your whole numbers. You have your booleans, which are just true or false values. You have your floats and your doubles, which are essentially two different types of values that can represent decimals, um, like fractions, for example. And then you have your chars or your characters, which are just individual, letters or symbols, for example. And then you have your strings, which are just, strings of text like hello world, for example. That would be considered a string. So, what if we want to group or initialize a group of similar things? So let's take an example. What if I want to represent fruits in my program? How would I do that? Well, one solution would be I could create a bunch of different string variables and set them equal to each one of the fruits that I want to represent. I could definitely do that. I could create a string variable for apple, set it equal to apple. I could create a string variable equal to pear and set that variable equal to pear. I could create another string variable, call it orange, set it equal to orange. But the only problem with that is you can see how every time you add a new variable, you add a new variable. So how do you keep track of that, which is the problem? And that's where arrays come in. So arrays are just, groups of similar things in a list. So in our fruits example, rather than having an apple variable, a pear variable, and an orange variable, I can just have one variable, call it fruits, make it an array, and I can store in that variable apple, pear, orange. I could even add banana. I could add whatever fruits I want in there. And then how I get that data out is I use what's called a for loop, which, if you're not familiar with what a for loop is, you're basically saying, okay, I want to start at this number and I want to increment until I get to this number. So for the case of arrays, what we'll do is we'll say, okay, I want to start at the very beginning of the array and I want to go until I reach the end of the array. And then, because we're iterating through and basically counting up, we have this additional variable, which is usually an integer value that is counting upwards. So we can say, okay, I want to get the array of this element, which happens to be the counter variable we're using to iterate through the for loop. And that's how we can get each individual index of the array. Similarly, you could, theoretically, if you knew specifically what point in your array you were trying to access, you could just say, okay, I want to get, the fifth element of this array. You could do that. That's generally not how people usually do it unless they're dealing with specific data that they know is never going to change, which usually isn't the case. But then what if we get into this idea of, okay, so I can represent things that are similar to each other, like strings or integers or doubles or whatever the case may be. But what if I want to show something or create something that I can't represent in these just data types? So let's think of an example. What if I want to represent a person in my code? How can I do that? Well, I can't really represent a person in any one of the data types that we mentioned. I mean, sure, you could have a string for their name, and you could have, an integer for their age, or a double or an integer for their height and weight, or, something like that. But how do you combine that into one thing and, you know, package it all together? Well, that's where this thing called objects come in, or specifically when you're writing code for it, you call it a class in most cases. But for the sake of this episode and for the sake of understanding, we're just going to call it an object because when you create it, that's basically what you're doing. You're creating this object, which the thing with objects, which is really cool, is when you create the object. So say I create this person object. What I can do is once I create that, I can reuse it anywhere I want, as many times as I want, just like I would do for, say, a string. So just like I can create, a bunch of different fruits for strings, I can create, a bunch of different people once I create this person object. So I could create an array of these person objects, for example. And you can just, build on them, which we're going to get into in a little bit. That you can build on these objects and kind of have a baseline, and then you can build on top of it. But going to the back to the person example for a second, how would you represent a person in code? So the first thing that I would do is think of what does every person have. So every person has a name, obviously, and every person has an age. So we're just, for the sake of simplicity, we're just going to stick to name and age. Okay, so how would you represent a person's name? Well, a person's name is just a string of text, isn't it? It's a string. So we can represent their name as a string. And then for their age, well, like people say, age is only but a number, so we can represent it as an integer value. And just like that, we encapsulated the string for the person's name and an integer for their age into one object, and it's called a person. And that's how objects are created. And obviously, this is a very simple example, but you can imagine when you get into these larger and larger projects, and dealing with, say, user accounts on social media platforms, for example, you can see how these objects would get very, very large very quickly. But because you can break them down into these individual parts, like the name and the age in the case of the person, you can break down this large object into these very small pieces and makes it a lot more manageable and a lot easier to understand. So I mentioned before that you can build on these objects, and you can, have a baseline and you can build on top of it. So what does that mean? Well, let's go through this example. So say you want to represent two different people. One of them is a software developer and one of them is a teacher. Sure, you can represent them both as person objects, but what if I want to get something more specific? Like, say I'm writing a program that takes in, people in their career fields, and I need to know specifics about their career field. Well, I guess technically, if I wanted to, I could just add additional fields to my person object and say for the software developer, add, what programming languages they know, which, since programming languages are just strings, I can represent that as an array since it's a, group of like things. So an array of strings for the programming languages they know. And then similarly, I could do the same thing for teachers. I could make an array of strings for the classes that they teach, since the classes they teach are just strings, the name of the class, and they're like things, so I can represent it as an array. But the problem is, if I'm creating a software developer, I don't care what classes they teach, since they won't teach classes. And if I'm creating a teacher, I don't care about what programming languages they know, because they don't know any. I mean, I guess unless they're a computer science teacher, but that's different. Well, I guess it's not different, but for the sake of argument here, they're not going to know programming languages. So you end up having this object that has this data field that just goes completely unused, and we don't want that. So how can we fix this? Well, there's this concept in software development called inheritance, and it's basically exactly what it sounds like. So what I can do is I can take, say, this software developer or this teacher and inherit the person object and create a brand new object. So basically what that means is if I want to create a software developer person, what I can do is I can say, okay, this is a brand new object. It's called software developer, and it takes everything that the person has plus this additional stuff. So because we mentioned that the person has a name and an age, the software developer also has a name and an age, And then, as we mentioned, they also have an array of strings to represent what programming languages they know. And then the same thing, we can do the same thing for the teacher. So the teacher, because the teacher is a person, we can say this is a new object called teacher. It inherits everything that the person has because the teacher has a name and an age. And they also have an array of strings for the classes that they teach. And just like that, we created two separate objects to represent both a software developer and a teacher using the person object without having to add a bunch of specific things to the person object that would no longer make it universal, which is the beauty of inheritance and object-oriented programming in general. Which is basically, what we're talking about here is object-oriented programming. So let's go into another example, kind of on the same topic here. So we mentioned that when you create an object, you can reuse it as many times as you want, just like any other data type. So let's take this example. Say you want to represent a sports team in your code. How would you do that? Well, a sports team has a name, it has a hometown, it has wins and losses, and it has coaches and players. So let's break down the easy stuff first. So kind of like a person, the sports team has a name. And as we mentioned, a name is just a string, so we can represent the name of the sports team as a string. And then for the hometown, we can do the same thing. The hometown is just, the string. What's the name of the hometown? So we can also represent that as a string. And then wins and losses, those are just going to be, whole numbers, integer values. So we can represent both wins and losses as integers. And then we have coaches and players. So you could make coaches and players persons, obviously, since coaches and players are people. But we want to make them a little more specific, kind of like we made the software developer and the teacher a little more specific. So what we can do is we can create a coach object, inherit from the person object, because obviously a coach has a name and an age. And then we can say, what they're the coach of. Are they the head coach? Are they an assistant coach? That kind of thing. And then same thing for the players. Obviously, players are people, so we can inherit from the person object because players have a name and an age. And then we could have additional things for the player, like what position do they play? What's their jersey number? So let's go for what position they play. So the position they play, that's just going to be a string, right? If they're a basketball player, they could be the point guard or the shooting guard or the center. If they're on a football team, American football, not soccer, they could be, the quarterback or the center again, or wide receiver, safety. And then if they play on a soccer team, they could be, the goalie or the forward or, whatever. So that can just be a string. And then their jersey number, I would think that's fairly self-explanatory, being just an integer number. So just like that, we can represent coaches and players as people and make them more specific to suit their needs. So, and then because we created this coach object and this player object, and we have multiple coaches and multiple players on the same team, because multiple coaches are like objects, we can create an array of coaches and store all the coaches on our team into that one array. And then we can do the same thing for the players. We can create an array of players and store all the players that we have on our team into that one array of players. So now that we've kind of walked through a couple examples, kind of breaking down what are data types, what are objects, and that kind of thing, let's go back to what I started this episode off with emails. So since we kind of know the keys to everything about the data types and the objects, let's try to work through this email example together and kind of show you that it's not actually all that complicated and see if I can, prove my point. So kind of like I've alluded to here with emails, I mentioned in the beginning, and I'll mention it again, there's a lot of parts that you have to go into an email, obviously, and how email works. But that's the key, right? Like we mentioned with the sports team and the person, there's a lot of different parts that go into it, but you can break those parts down into individual data types, and then it becomes basically trivial. Like we mentioned with the sports team. How do you represent a sports team? Well, what does a sports team have? They have a name, right? Well, what is a name? I mean, it becomes that trivial once you can break it down into these really small pieces. So, let's go through the email example, shall we? So, what does an email have? Well, an email has the sender of the email. An email has recipients so basically who's the email going to. It has a subject, it has a body, and then it has the time it was sent. And for the case of my email application, that's all it had. Obviously, in the real world, you can have attachments and things like that, but for the sake of simplicity here, we're just going to stick to those things. So let's go through each one of them real quick. So the sender. What is the sender? Well, the sender is an email address, obviously. And an email address is what? It's a string of text, isn't it? So we can create an email object here. And this email object will have a string variable called the sender, and it'll be set to whatever the sender's email is. Okay. Now let's go on to recipients. Well, this is where it can get a little bit tricky because you can have one recipient, you could have two recipients, 3, 5, 8. You can have basically as many as you want. So how would we represent a possible grouping of like things, that being recipients? Well, we can represent a group of like things with an array. So we can have an array of recipients, which will just be a string of these email addresses, which we already found out that an email address is just a string. So we can have an array of strings for that. And then we get to the subject. Well, what makes up the subject? Well, the subject is just a string, isn't it? It's, whatever your subject is, like, check out this, cute cat video or this cute dog video I found, or, whatever your emails that you're sending these days are. So yeah, that we can just represent that as a string variable as well. So now we've gone through 3 of the 5 things that we talked about what makes up an email already, and I'm not sure about you, but I think so far this has been pretty simple. I'm not sure about you once we've, broken it down and kind of walked through each one of these steps. So let's get on to the body of the email. So what makes up the body of the email? Well, when you just write a plain email, you're just writing plain text, aren't you? So we can just represent the body of the email as another string. So let's recap before we get into the last one, because the last one can be a little bit tricky. So we have the sender, which is an email address. So we can represent that as a string. We have our recipients, which is a group of like things because they're all email addresses. And we just mentioned with the sender that an email address is a string. So we can have an array of strings to represent all of our recipients. Then we have the subject. The subject is just a string of text of what you're saying the email is about. So we have a string for that. And then finally we had the body, which the body is just a bunch of plain text that we can represent as a string. So then here comes the part that can be a little bit tricky, which is the time it was sent. Now, the reason this can be tricky is because time and dates technically don't have their own data types. Technically. I say technically because in basically any programming language you'll be writing in, there is a date and time object pre-built into the language. So because of that, we can just represent it as the date and time object, which, as we already previously mentioned with objects, it's basically just different data types, combined into one thing to make an object to encapsulate everything into one. So if you really want to go deep into the date and time, You can think of it as like, maybe a string for if you wanted to represent the months or days as strings, you could do that. Or you could just represent them as numbers, like 12 would be December, 1 would be January, and then for the actual time, you can represent it depending on if you're representing it in a 24-hour or a 12-hour schedule. Um, you could just represent it as a number 1 through 12, or and then have an AM PM type thing, or have just 0 through 1 or 0 through 23 for the 24-hour. um, but as you can kind of see, you know, you can break this concept of what is a date and time down into, what is a date and time. It has a month, and you can represent that as either a number or a string. And then you could represent the actual time as, integers for the hour, the minute, and the second, that kind of thing. But for the sake of simplicity, why reinvent the wheel when we can just use the built-in feature with the programming language? So that's what we can do with this example. So how does an email work? So we created our email object, which encapsulates everything that an email has. So we found out that an email has a sender, recipient, subject, body, and the time it was sent. And we just went through this example of how we can encapsulate that into just one object. So now that we have our emails, how do we send emails? Well, first we have to go back to the senders and recipients. So, senders and recipients, we determined, have email addresses. Well, how do I get an email address? So, in the real world, you can go to either Google, Yahoo, Outlook, AOL, wherever, and you can sign up and create an email account. In the case of my program, you could just create an account, and then whatever your username was is what your email was. So it'd be like if you created your username, in my case, as the Dark Assassin, it would be the Dark Assassin at, I think I just said mail.com or something like that, something basic. But, that's just the domain name. That's not, which is tied to the email, but you can think of the domain name as its own separate thing, since the domain name is either at gmail.com or at yahoo.com or whatever the .com or .net is. That's the domain. So we're mostly focused on the username aspect of it, which is what it would change from account to account in this example. So for my program, what I did was you would log in, you would create an account, and then whatever your username would be, it would just be that at, basic domain. So we come up with this idea of user accounts. So what goes into a user account? We can create another object here. So the user account, you're going to have your username, obviously, which is, again, the username is just a string of characters. So we can represent that as a variable of a string. And then you have your password, which passwords are its own separate thing, which I'm not going to really get into with all the different aspects that go into a password. But for the sake of simplicity here, you're going to have your password stored as a string of text. Now, whether you have that encrypted so no one can be able to read it or whatever, it's still going to be a string of text. So we can represent the password as a string. And then you have your email address, which, as we mentioned in our email example, is again just a string. So here we have our user accounts, where we have a string for the username, a string for the password, and a string to represent the email address. So since in my example, I never were sending anything like across the network, everything was just kept locally. How I solved that problem was I gave every user account emails. So how would I do that? Well, think of your inbox when you open up your email. You have just a bunch of emails in there, right? And what is a bunch of emails but a bunch of like things? And because we have our object, which is an email, we can create an array. So we can have an array of emails that were sent to us, which in this case would be an array of emails where our email account, which is, we have in our email account object, in our account object here. So where our email address shows up in an email's recipients list, that email would then be stored in this array of emails that was sent to us. And then similarly, every email we send, we can have show up in this array of sent emails, which that's even easier to do because if we're the one that's sending the email, we can just put it right there. We don't have to do any kind of, calculation or fancy trickery work to figure out where it's supposed to go. So that's how we can solve that. So I kind of teased it a little bit here about the whole sending email thing. So we have our user accounts object and we have our email objects. So say I want to send an email to Bob and Jane and Bill, for example. How would that work? So I would type up in my recipients, I would type up Bob, Jane, and Bill. And then I would put in my subject. And then I would put in whatever my body is. And then I would hit send. And then when you hit send, you can dynamically get the date and time object, which is the really cool thing about the date and time objects that are built into these programming languages is you don't have to worry about anything. You can just get the date and time, and like that, you get the current date and time, which is really cool. We don't have to do it ourselves. It's done for us. So we can get the date and time once we hit send. So we can save that in our email object. So we got the date and time. And then I mentioned the email that we're sending it to. We're sending it to Bob, Jane, and Bill. So we typed out their email addresses, so we can just store each one of those email addresses in our array of recipients in our email object. So that's 2 down, and we got 3 to go. Obviously, we're the sender, so we know our own email address, so we can store that in the sender field of our email object. And then for the subject, we can just pull what we wrote for the subject, store that in our subject field, and then take what we wrote in in the body of our email and put that in the body field. And just like that, we have an email. So now that we have our email, we can store it in the appropriate arrays. So since I'm the sender, I can just take this email object and copy it into my array of sent emails, and there we go. Now, what about for Bob, Jane, and Bill, though? How do we send the email to them? So what we can do, in my example, since I wasn't doing any kind of networking, everything was just local to the application, like I said, what we can do is we can take a list of all of the accounts that's on the system. So since we have a list of like things, we can have an array. So we can iterate through the array of user accounts and basically just check, okay, is this user account? Let me grab their email. Is the email for this user, is it in this array on the email of recipients? No? Okay, well, let's go to the next one. And we can do this through the for loop that we talked about earlier in the episode, where we can say, I want to start at the very beginning of all the accounts, and I want to go until I reach all the end of the accounts. Or since we have a finite number that we know we're looking for, we can break off of that for loop once we get all the recipients, so we're not wasting processing time. But we can get into that into another episode when we can talk about optimization and that kind of thing. But the premise is this. So you want to start at the very beginning of all your user objects for your user accounts, and then I want to step through each one individually, and I want to check if the email that's tied to their user that's in their user object. So for example, mine, if you looked at my user object and you got the email from it, it would, be thedarkassassin@mail.com. So what I want to do is I want to go through each one and I want to pull off the email and just, check it. What is the email of this user account? And then is that email in the list array of recipients in this email object? If it is, then since I'm already at this user's account, what I can do is I can then add this email object that we have here that we just created to that array, and then essentially the email will be sent and delivered. So now that we kind of have this understanding of how the emails will be sent and everything, how would we set up the interface for this? So, interface design is definitely not my specialty. And I will agree with all of you that some interfaces people make is 100% witchcraft. I don't know how it's done. I'm terrible at them. Graphics are the bane of my existence. Yeah, it's not fun. I don't know how people are good at them. I have zero artistic ability. But that's that's complete sidetrack. But I mean, pretty much the sky's the limit when it comes to your user design. You can make it as simple or basic as possible. When I made mine, I pretty much had a column on the left-hand side that you could select if you wanted to have your inbox or your sent messages. And really the way to do that is for your inbox, you can basically just grab your array of emails that were sent to you and then just, print those out. You could print out the name of who it was from, since every email has a sender attached to it. You can print out that. And then you could say print out the subject and then maybe, like a line or two or however much room you had for you could print out, a little bit of the body. And then similarly, you could do the same thing for your sent emails where you could, when you click the sent tab, rather than pulling from the array of emails that were sent to you, you would then pull from the array of emails that you sent. And then what you can do is I just made a super basic kind of user interface for setting up for actually being able to send an email. So there would be like a text field for the sender, or not the sender, for the recipients. I split it up into a to and a copy, a CC, one, just to kind of split it up. But I mean, in the end, it's being sent to everyone, so it really doesn't matter how you do that. Um, and then I would have the subject, just a text field for the subject, and then a big old text field for the body where you can write whatever you want in there. And just like that, we have an email application, ladies and gentlemen. We created an email application, this large kind of enigma that we thought was super complex. In the matter of minutes here, we broke it down into small pieces, down into what makes up an email, down to a string for a subject. That's how far we broke this thing down. And then we put all the pieces back together and built it up and created an email application. And that is the essence of what software development is. You take this really big application or idea, and then you break it down into smaller and smaller pieces until you get to essentially the individual data types and how you can represent them. And then you slowly, piece by piece, build everything back together until you have your full application, like we did with our email example here. So as we just demonstrated, you can break down these ideas that seem really big and complex and down into small pieces. And that's how all these big tech companies out here, basically build their software. So when you think of the Googles of the world, the Apples, Microsoft, Facebook, yeah, you heard me right, Zucky boy, I called it Facebook. Deal with it. All these companies, they structure their software development in this way where they break everything down into smaller and smaller pieces and then just, create their applications. So if you take iOS, for example, every single one of the apps on your iPhone or your iPad or well, I guess technically that's iPad OS, but it's basically the same thing. Um, so, you have all these applications that are built by Apple. All of those, I can guarantee you, I don't work for Apple, but I can guarantee you each one of those applications has at least one team dedicated to it, if not multiple, that then gets each one of those individual tasks, it gets broken down into smaller and smaller and smaller pieces until you have, this one application. So another idea kind of in the software development world is this idea of sprints and tasks and, milestones and that kind of thing. So what you can think of that of as is if you think of a sprint is comprised of a bunch of tasks, and those tasks are generally not they're more complex than create a string variable, but they're broken down. So you, for example, for our email application, a task could be create the email object, for example. That might be a task. Or create the user account object, for example. Or another task could be send email, like add send email functionality. That could be a task. And then the sprint comprises, multiple of these tasks into one thing, which could then be, a couple week process, or, the team can decide on how long they want it to go. But then you have multiple sprints that would then comprise a milestone. And say your milestone would be, for the email application, you're able to send and receive emails from accounts. And then another one would be you have a user interface. And then your final milestone would be you brought both of those together and you have your final email application, for example. That's kind of how it gets broken down, where you have, the large project, break it down into milestones, break those milestones down into sprints, break those sprints down into tasks, which usually you break the milestones down into tasks, and then the tasks get divided up amongst the sprints depending on, people's abilities and that kind of thing. So obviously I will admit, like I said with the whole graphics thing, I went on a little tirade there. There is some things in software development that even I do admit is kind of crazy, and it is very impressive how they managed to do that. But I hope in this episode, I at least kind of gave you an understanding that it's not actually wizardry and witchcraft, and us software developers aren't, you know, at our alchemy tables with our magic wands and our wizard hats and all this stuff. We're just, normal people. We just think about these projects and tasks differently than, someone like you, for example, that you might not think of how does email work? Like how would you even start? Whereas us, we're thinking, okay, how can I break this problem down? And I think you can apply that to a lot of aspects in life too. In whatever your field of choice is of you listener. I mean, you probably have ways of breaking down tasks for, the field that you're in that I would never fathom. Like say you were, a physicist or a astronomer or something. I mean, there's a lot of stuff in that field that, goes way over my head and I think is kind of, black magic witchcraft, but, maybe you're listening to this podcast and, you have your own podcast and be like, "Hey, I do the same thing just for physics or for math or one of the things that I find that I never understood was the whole medical field. All that goes way over my head. I don't. Whenever I hear them talking about, these Latin names for all this stuff, I mean that's way over my head. So the point here is I don't expect you to be able to understand everything about software development and become, the next Bill Gates and write the next breakthrough operating system with this. But the point is that hopefully you're able to get, kind of a better understanding of how it works and what goes behind software development. And it's not just, witchcraft. It's, an actual process and, we break things down and try to make it into these really small and easy tasks that we can knock out quickly. And that's why us as software developers kind of think of it easy, which, I mean, if you think about it, if my whole job is just a bunch of tasks of, say, create three variables, I mean, that are strings, I mean, I think that's pretty easy, wouldn't you? I mean, I just type, string, name of the string, and what it's equal to. I mean, it's pretty simple if you once you break it down into these really small pieces. So I hope you enjoyed the episode. If you did, please give it a review, give it a rating. And if you have any comments or topics that you want me to address in a future episode, you can leave a review and put your comment in there. Or I have down in the show notes below an email address, contact@darkassassinsinc.com. Send me your questions, and I'll try to incorporate it into another episode of the Dark Assassins podcast. So until next time, my fellow assassins, remember, bull nothing equals true. If action not equal to null, return true. I'll see you next time on the Dark Assassins podcast.